So this is a machine mounted on an elastic support with a negligible damping. So in this case, zeta equals to 0. Okay, so suppose this machine is mounted over here. This is moving with X, this is also moving with foundation, is also moving, vibrating like a washing machine mounted on the rubber pads. Like these are the mounts without the damping here, in this case with an amplitude. So the amplitude is x1, it is 6 millimeters at frequency 1, which is 3 hertz, and x2 equals to 9 millimeter at frequency 2. So determine the resonant frequency. So we have to find out the omega n. So if I go to the table, let us use this table, transmissibility formulas for base excitation. So I'm gonna use this displacement transmissibility for this question. So in our case, when the machine vibrates, which is the amplitude of the vibration, which is x1 and x2, so you see that I can use this formula here. X1 equals to y, and over here it is zeta. In our case is 0 because it says negligible damping. So I can rewrite this same formula as 1 over 1 minus r squared whole square, correct? And x2 equals to again y. This would be r1 squared, this would be 1 minus r2 squared. So if you do the math here, just do this either x1 over x2 or x2. So let's do x1 over x2, which is equal to 1 minus r2 squared r1 squared, correct? And what is x1? X1 equals to 6, and this is 6 over 9. So left hand side is 6 over 9. So this one is omega over omega n2. So r equals to omega 2, r equals to omega or omega n. So r2 equals to omega 2 over omega n, r1 equals to omega 1 over omega n. And let's do this over here. What is omega 2? Omega 2 is 2 pi f2, which is 6. Two pi f1, which is 3. So you plug it in over here, so it is equal to 12 pi. So I can write out 1 minus 12 pi whole square over omega n squared 1 minus 6 pi whole square over omega n square. If you solve for this, so it's the same thing. That means omega n, you obtain this answer 59.6 radians per second. That's how you will solve this problem.